Hello, welcome to another Blender Sushi live noding session. Today, again, I will be exploring animation nodes, and we will cover kind of like intermediate topic. I previously tried to do this using drivers, Blender's own drivers, and then also I use Verchalk in order to do this. And today we will be doing it using animation nodes. It's basically we will be using the Blender displace modifier, which is this one, and kind of measuring the distance between the original position of vertices and then the displaced vertex position. And with that value happening, we can actually trigger it to do something else. And it's a lot easier now today using animation nodes than previously using Blender's drivers or kind of Python hacks or even Sverchok. Sverchok is also actually quite interesting, but a little bit more complex. But using animation nodes, it's really simple. I'll show you really quick. Maybe I will be using a flat plane in order for you to see what's happening. So I will create a grid. And with grid, we have like a bunch of vertices. I believe it's 81 vertex. No, actually it's 100 vertex, so it's 10 by 10. We look at the points right there. So we have like 100 points there. And I will turn on the wire. Yeah. And I have this grid, right? And then I will use the displace modifier, and by using displace modifier, by default it's pushing the vertex up based on the normal of the surface. It's kind of like mid-level. I believe it should be, yeah, we can change that later, but basically this position compared to the original position at 0 strength, that's the original position, and that's the displace position, and we will use those value and pipe it into animation nodes and do something cool. Okay, let's do it. Let's go to change the layout to compositing, and so we have this. Leave that. We're gonna switch to animation nodes and create a node 3. We're gonna get a, for purpose of understanding this, I will do it like this for now. So we have, this is the displace position. So we have the mesh data. We're gonna grab the same mesh data, but the second one will be using the modifier, which means there are two states: the default state and the state after the vertex being displaced by the modifier. They're still sourcing the same mesh data, except that they have like a slight differences, and we can use both inside animation nodes. So we're gonna create a loop, program loop. Okay, this is our loop node, and we're gonna create two iterator. It's gonna be the vertex list, two vertex list, second one being displaced, right? And do it like so. Vertex list and pipe in. It's the same. It's kind of, it looks the same, but it's not. You will see soon later. And we can use distance. We will be using distance, like the vector distance. That's our key node there. Vector distance. It will measure the difference between those 2 points and spit out some new data. With the vertex, we need a vertex info node. And then we can measure the locations. That's actually the basic idea right there. So with this happening, let's quickly save it. Animation node displays trick 001. Save Blender. The distance, let's debug it. Let's see this value and debug it. So we debug loop, pipe in the data. Want to see the data? Let's have a look. It's actually displaying 0.5. 0.5 because of this value. So we can leave it as 0.5 for now, but I'm more interested with the strength right here. The strength from 0 to, or even it even can goes under 0 and more than 0, so we can push over and under the normal value being between 0 and 1. So that's actually our setup ready. Really easy, really cool. And by comparing the two states of being the default position of points or vertices and the points being displayed, so of course things can start to get interesting when you use texture. For now, I will leave it like this, and then I will use a objects instancer. Real quick, I will create a, let's see, what's the easiest? Icosphere. Yeah, icosphere. And scale it down so it's like about the same size of the vertex. Object instance, and we can instance these things. So I'm gonna create an object instancer. Search object instancer. So that guy, and we can put it in the same loop. We can have a loop within loop within loop, but usually one loop is enough most of the case. And let's see, we're gonna create a new iterator, which is our object instances object list. So we're gonna pipe that in. We're gonna grab this guy, will be copied into each and every vertex. So let's grab it. How many? The number of instances, usually the length, like the total number of the vertex, and we can simply pipe that in. Animation nodes will create a get list length node automatically, so it creates the copy of these objects, right? And we can use object transform output. And which location do we want to have? We actually gonna use the original position, like, yep, wait, we have to activate the location, drag that in, pipe the objects in, so we have that happening. So this guy is the ghost, I mean that's the displaced vertex. Normally I will just I'm gonna turn it into wire like that, so that's a displaced. Yeah. And next, what we're gonna do next? I will actually using this vector distance that's comparing the points between the default position and the displaced positions, we can easily pipe that in to the scale like that. Very easy. And then the lines, don't worry about the lines, we just gonna hide it. Object instancer, advanced node settings, hide relationship lines. Alright, so this modifier will control the size. Just that simple. Actually, if we change the textures, you will start to see interesting stuff happening. Let's add a texture, new texture, and then jump into the texture tab. It's this guy. You can use your own image. Usually grayscale image will work best. And let's use cloud as an example. So this cloud drive the value, and okay, so this guy is actually driving the scale of our copy like that. Can increase the strength, for example. So the value goes up and down, and maybe the mid level should be 1 or 0. Maybe 0 is okay, and put the strength into 1. Mid level. So mid level is kind of like an offset kind of way. Strength, we can have a play. So that's actually, yeah, that's actually it's kind of like you have a texture in which the texture itself is kind of like a math formula happening right there. It's a noise functions. I believe it's Perlin. Is it Perlin? No, it's Blender Original. You can change it to Perlin. Perlin is probably slightly more complex. Empty. If you use an empty, for example, to drive the texture position, that's the thing that I always do, and it's a cool trick, and it's always fun to show this to people. So the texture applied into that is displacing this mesh, we will be controlling it using the object position, which is our empty, that right there, the locator. So by moving the locator, you get this kind of effect, right? This is basically what I'm trying to show you. Yeah, it's really cool. I could probably show a slightly different configurations, but this is pretty much it. And let's say maybe you want to drive the color as well. The color, should I do it right here? Maybe I should. The color, okay, with the color, usually I'll do it like this. So we have our this setup that's working. I'll save it. I'm gonna save another new version. Do save a lot. It helps you to keep progress of what you're doing, and also keep notes. That will help. And if you're thinking to make a similar tutorial, show this to your other Blender friends or non-Blender users, show this to them, and then they will be like, wow, that's possible in Blender. Of course it's possible. There's a lot of things that Blender can do, and people just don't know it. Okay, this okay, what I was gonna show you, the color. Okay, color. let's create a new material for this guy. So we just need a new one material, and this material, let's call it just material 1. This material will look at the object color. If you're using Blender Cycles, it's gonna be slightly different. You're gonna be thinking about vertex color, but with Blender renders, and for purpose of this showing this and teaching you how to do this, I'm just gonna be using Blender render object color, which Blender can display on screen like real quick. Object color, so because you can go to with object color you should look at my previous tutorial about color. So color, you can change it right there. Yeah, it's not changing my copy because I need to turn on copy full objects. Maybe deep copy. Oh, I don't need deep copy, I guess. So that guy, so we'll, in order to drive the color of those each and every copies, we can do it using the attribute editor. Attributes output node. So yeah, hopefully animation nodes will have like a attribute transfer node maybe we can do that using the BVH and KD3 as well, but I don't know. I think transferring attributes from one point to another point, basically, that's can be really useful. So we are controlling the scale. So we are seeing the scale now. Using that value right there, you can pipe in into anything. Color. So we want it to be color. So color is special. Color is for data, kind of like list of 4 floating value. So that's our color right there. And so we're gonna grab our object. No, we're gonna control the attribute color, which is the object color right there. If you hover over it, you can see Python object.color, right? And we just pipe in the objects, and now this node knows. Okay, this node knows what data type it needs. It's actually, this value should be turning yellow. I think yellow is for color. Let's try. Okay, it turns black, which is a good sign. It's RGB A. This is the alpha. Alpha should be 1. RGB red, green, and yellow. RGB looks good in Blender because I don't know, maybe it's just the way it's displaying. It's not displaying like in full value of 1. It's kind of more subtle, like a darker RGB, so it looks good. Color, object attribute output. If you like, you can actually rename node. I mean, give it a special label, like this is colorize to colorize copy. So that's, and then you can just minimize this. Okay, this node is gonna be our colorize copy. And of course, I usually, in order to differentiate, oh well, actually maybe okay, I'm just thinking, okay, we can do it like this. Because the distance is a single value, we're gonna try, what if we pipe in the distance, this distant thing into that thing right away. So we have float to vector, vector to from value. So that's a float value coming out So it's actually that value right there. It's pipe that in, boop, and this is a vector. The funny thing is, okay, this is we have these 4 values here, and we need to use it's a vector. It's decompose or something, or separate vector. So it's a separate vector. Yes, separate vector x, y, and z. Boom, we have something that's more like a grayscale value. It's grayscale, and the cloud, this cloud is driving the value right now. Yeah, it's very subtle. You might not be able to see it because the value is if you look at this value, it's kind of, most of the value is pretty high. Maybe because of maybe because of the mid-level as well. The strength, each one of them is responsible for this. In order to make our value more contrasty, more between the range that we like, we can use a map range node, and whoopsie, this map range should be before, and let's do like that. So the range of map, we should look at the smallest value and then get a maximum value. You can use a fancy thing like a math min and max. I believe it should have min and max, and it's actually not map. It's probably under list. If you type in max, list compare, is it compare? Get list element. One of the list is, maybe it's a filter or something. One of the thing that can actually look at the value of every value and then find the max and find the minimum, and you can plug the number exactly. For now, we're just gonna use our eyes, and then okay, so it looks like the minimum is around 0.5. So 0.5 is okay, and 0.5 and 1, the value, some values goes up beyond 1. So maybe 0.6. So you can see black being like no, the vertex is kind of like almost not moving, and white being the vertex is being pushed really far. So we can see our cloud kind of this pattern. I love pattern in computer graphics and in real life. I look at the pattern in nature as well. So this is like the basis of a lot of art, like a creative type of works. Sometimes they call it generative art. You look at the nature and then you're trying to simulate that in CG, in anything, even in particles movement and all kind of stuff. This kind of movement, which is it's called cloud texture, right? In often called clouds, actually Perlin. Thanks to Mr. Perlin, we can have this cool stuff happening. And sometimes with a texture like coordinate being controlled by a locator, you might want to scale your locator, or scale down, scale up, and that can change the texture. You can see that's actually a quick way to change the scaling of the texture, and then that will affect the result. With sphere, sphere is cool. Sometimes you want to use cylinder. With cylinder, you can have like a scale to control the height of the cylinder. So maybe I should do that. Cylinder have a lot of vertices. We can reduce it to maybe 6, and so it's more like a honeycomb kind of looking thing. Some people like it like this more, so make it small, just like our sphere. So that's our master, and then we're gonna create a clone, create a copies for each. And since this is like procedural, we have all the systems happening right there. We can simply replace the icosphere with our cylinder. And okay, actually let's apply the same material, that material 1, and let's just source that guy. Okay, we have this thing happening. If you are using a grayscale image, and then using the UV, you can have like a texture. Let's say like a face, like a portrait, like your portrait, for example. Or you can even make it live using a webcam and then pipe it into Blender, and then you will see a grayscale happening. It's kind of like I believe it's been done. There's an artist using processing, and then he created this kind of like a mirror. So if a person is standing in front of the webcam and then look at the webcam, it will drive like a mirror. It's actually really cool, really cool effects that you can replicate using Blender. Just to drive the rotations, kind of the rotation of each object being driven by the displays, by the value, the grayscale value like this that we have already set up. So right, that guy, should we make it smaller? We can make it smaller. The pivot of the object is right there at the moment. I think using animation nodes, you can change the pivot of each copy. One thing to keep in mind. So that guy, what are we going to do? Oh, cylinder is a cylinder, so we can scale the, let's see, it's a scale Z. Instead of piping the vector distance all into 3 output like this into the scale, we're gonna use another separate vector. And the X and the Y should be 1, not changing, but the Z should not separate vector, it's more like combined vector. Combined vector data, we have the X and Y should be 1 or different value, and the Z coming from the distance, plug into this guy, and yep, it's actually working. But we make X and Y smaller like that. And the scale itself is being driven by the distance. So yeah, like that. It's really cool effect, kind of like a push pin effect. I did this like 10 years ago or 15 years ago in Maya. It was a pain in the ass. Actually, in Maya, maybe if you are using mesh plugin, maybe you can do something like this. Back then, I was using this Displace D add-on created by Mr. Hajime Nakamura. He made this plugin for Maya that the plugin does exactly what a displace modifier does. And then in Maya, somewhere, this is talking about Maya, right? Someone make an add-on that does this displacement, and it's called Displace D. Displace D is really useful. It's doing exactly that, and then at some point 10 years later or 15 years later, Maya finally decided to create a displace modifier. So it takes Maya that long to create something like that. Anyway, it's now it's 2016 and we have this in Blender. Really, really, really cool scale. You can of course create more or less of the copy to see it better. At this moment we have we are actually using this mesh, right? We can subdivide more of this mesh, but we will not do that. Let me save this and then create a new version. Instead of using the grid, now we're gonna do something really scary, like kind of deleting this and this, but we're gonna do that anyway, so we don't have our things happening anymore. We're gonna use the grid mesh generator grid. We have our grid right here, and with this grid what's gonna happen is, so this will create the grid, right? But in more like in the animation nodes kind of environment. Grid mesh, it's 5 by 5 points. We currently in our setup we are using vertex. Okay, maybe we can use mesh data, combine mesh data. Let me think. Mesh data. Object mesh data from polygon, create mesh data list, separate mesh data. Vertex location is not giving us vertex list. Great. Vertices, mesh data. Okay. Mesh data. I should not have done this. Mesh data, object mesh data, mesh data from object. Yeah, this is actually interesting. So with mesh, by looking at these 4 nodes, I was thinking, hey, this is interesting. Actually, so we have grid mesh. It doesn't have information like a vertices yet until we pipe it in. Vertices probably have idea about the normal. So what we can do here, we're gonna use all these 4 nodes to get what we have before. So we have this guy, and soon we're not gonna be using this mesh anymore. So vertices goes into there, edge indices, the polygon indices goes in there. We have now the mesh data. Mesh data, we're gonna output our mesh data. See, output the mesh data in there. Turn on the mesh data. Do we need the objects? I'm not quite sure, but what if we plug that in? Oh, we probably need an object. So that's gonna be our target. So that's our grid, right? Our super grid right there. Wire, draw all edges. Simple grid, 5 by 5 because it's 5 by 5. And we have our vertex list. Cool. Vertex list. And we have that use modifier thing happening. You can actually at this point you don't always need to create a mesh like this. Sometimes you can just have the vertex. This can have a use like if you are using UV. Anyhow, it's piping the original value right there. Maybe I'll create another one. Let me think. Original vertex, vertices. Well, just create another one, I guess. Oh, if you're doing it like this, it's gonna use the same thing. Okay. We are going to do it like this. Hopefully it's not causing a cycle. Maybe it's not doing. So apply a modifier, displace it like that. It's pushing it down. Giving it a texture, our cloud, strength of 2. Yeah, we are almost back to where we was before. And with this guy, we gonna source it, and this guy is looking at the modifier. Plug our vertices in. Maybe have more divisions, like 8. And texture coordinates being driven by our object. Okay. And let's have a look at our data. Do we have something going on happening? We don't see anything. So our grid mesh is outputting that guy and that guy. Looks like we can't do it like this. We actually need a 2 objects, so this should be target 2. Mesh data is the same. Plug that into there. Now we have 2 objects. So that's our second object right there. We're gonna use displace modifier driven by the same textures and check. It's our empty, strength of 2, mid-level of 1, so we have exactly the same. So the default will be, so with this guy we can get rid of the modifier. We have the original position and that the one being pushed. Save this, mid-level 1. Where is all our copy? Let's investigate this guy. Let's see if the thing's actually working properly. So cut that, pipe it in. It might be a bug, but let's see. It's our icosphere. So we have that. Get list length. Okay, we forgot to pipe this in. So it's not actually a bug. It's still happening. We just need to reconnect that. Super interesting. Just remember that that's the thing that's connecting to the object instancer. Maybe the setup can be more elegant, but that's cool. Everything's still happening. So this guy can. So apparently we can actually do it like before without. We don't need the second object. Maybe we can just pipe that guy in here. Let me save just in case it crashes. Pipe it in to there. And this guy is being driven by displays modifier 1, strength of 2, texture. Yeah, it's actually working. It works like that. We don't need the second target object. That's actually really cool. It's creating two different states. Let's turn this into wire. This actually creates two different states, one without modifiers and one with modifier. I'm really happy that this actually works. Awesome. So we have our okay, texture coordinates being driven by object. Object should be our empty. Empty is driving the texture. Texture is modifying and displacing our mesh. This ghost guy right there, and it's driving the scale. The scale can be also remap. So remap is very useful. This is super handy. So the value goes into the value, and the output of the map range goes into the Z. And by doing that, you can have control over that. So we are remapping the value between 0.6 and 1 into 0.8. This is also used a lot in computer programming, remapping value, and you have this really cool effect. Sometimes we need that, and we can actually hide this ghost object, so because you don't need to see it anymore. Hide it. We don't want to select it. We don't want to render it. Okay, so back to where we were before. We don't need to see camera and light for now. We have cool effects. You can render this out. It's all procedural. You don't need to bake it. Sometimes you want to bake it just in order to see it playback in real time, because you can render it using render cycles or even pixel renderman. Everything will work, and you can change your setup. You can increase the grid. Since we have our setup, the reason we have this guy here is so that we can have more and less grid. Yeah, more or less as you want. Like that. Yeah, really cool effect. And you can have it. All right. And if you feel if you want these guys to be, if you want to have control over the pivot, I believe there's a matrix. I'm still not familiar with the matrix thing, but there's a change matrix pivot, and normally I use this object transform output all the time because it's simpler, but you might want to use matrix output. It's kind of the same thing. No, actually, matrix one will be more sophisticated, I believe. Object location scale, matrix, position, location matrix, position matrix. Matrix thing is confusing. Translation. So translations, you have location before and after. You want it at the before positions. This goes into, this will be, this will go as a pivot location. Okay, we don't need, so pivot, there's a pivot, transform matrix. I believe what's happening, we have everything disappear right now because what's happening is object transform output is overridden by the object matrix output. And matrix translation rotation scale, let's compose matrix for this guy. Compose matrix is almost the same as this, except that it's separate. So that's basically what it is. And object location scale, location, this is the scale. Rotation, we don't need to worry about rotation at the moment. Location comes from location, this is the original. This plug in there and this plug in there. That's it. And let's get rid of this. Scale, translation, position. Pivot location is coming from there, and that's translation coming from there. So maybe I did something wrong. Maybe the pivot can come from the second. Maybe this comes from there. Yeah, okay, that's a displace position. I think we have it correctly. Okay, not exactly at the center, not exactly at the bottom, but that's a start. Maybe that position right there. Maybe we can use vector math and let's place the z right so. Control it. Yeah, I believe the answer is there with the pivot location. I'll probably need to confirm with Jack's look about this. Kind of need a way for animation nodes to place the objects to change the position of the pivot procedurally. Huh, interesting. No, pivot location should be the original vector, of course. It's kind of more like, that's more like it, I think, even though the bottom is still moving. Oh well, at least we have this happening now. We have control over the distance. That's 256 copy of object right there, doing a cool thing. Can save this file, save as, save this guy. With the texture, if we select our target object and look at the texture, at the moment it's cloud is like that. We can actually, it's real time. That's what I like about procedural, it's real time, and you can change the texture, and it will update in real time. The coolest, actually my favorite is not cloud. Cloud is also cool, but I like wood, because wood will clearly display what's going on, what's happening. So I scale. So when I scale the locator, we can see exactly what's going on. That's our value. Maybe maybe our displays can be changed into strength of 1.5, not 2. And we can control the locator, and it's changing, and you can see the stripe like that because look at the texture again. That's what we have right there. So it's just stripes. It's actually a sine wave diagonally moved that way. So a sine function applied to create this beautiful stripes pattern. I really like this. This is so useful in teaching people about math. So if you have something like saw is more like that. If you, since this blender, okay, we can solve is like that. Everybody, solve function is like that. Sine function is more like that, like this. Smoothly goes up and down like wave. And try, I'm not familiar with try, but you can see it's happening anyway. So let's get rid of the grease pencil. And delete grease pencil. Back to where we were. Let's try with sine. We can have ring, ring, ring. Ring is kind of let's decrease and increase the size. Maybe it should be like that. Anyway, that's ring. Pan noise, ring noise, saw, sine, Voronoi, Carlin. No, it doesn't work with that. Oh, I like that. Sine and ring noise. You can see it. It's happening. Can't see the center at this moment. Maybe I need to scale it really big. Oh yeah, there you go. That's the center. Looks like it's having like a kind of, yeah, that's really cool effect. You can play all day using this. This is having the opposite effect at this moment, which is interesting. Maybe the UV is flip. Maybe I can just scale it in x minus 1 so it flips. Something to consider. Maybe the normal need to be flipped in order to make this works, or we can just flip the value up there, the term matrix. Well, anyway, you get the points, and hopefully you like this tutorial. I will do more interesting video tutorial next, but this should be fun for you to try to understand. If you understand this is kind of like a good intermediate level of understanding, and you're kind of hack like a Blender. We're using Blender modifier, and by using this on top of this, we are driving everything using animation nodes. It's kind of like drivers on acids. Once again, it's drivers on acid, everybody. And it's really powerful. I don't know the limit yet, but with animation nodes it might be a little bit slow, but slow will be faster eventually when it's improved. And then we have limited nodes probably at this moment, just all this bunch of nodes. It's good to get you to understand procedural workflow while thinking about each one of Blender features. And then if you feel like to get into more, you probably want to look at into the script node, and then try to use your own Python script and then run it inside animation nodes. It's really cool. So I love this animation nodes a lot. Thanks to Jax Luke again for this add-on. Yeah, I switch back between Blender and Houdini. I think I like Blender because it's yours, it's open source, and you can just do whatever with it. Make your own work and sell it. It's licensed. With Houdini you have to pay license, of course. Or my yeah. Okay, hopefully this is useful for you. You can make like your own procedural artwork, procedural art, maybe in a gallery or at your own school or university. Hopefully this is really useful for you, and have fun and enjoy.